And section 05 is about algebraic, not expressions. We did expressions on Friday. What's this? Equations. What do you think an algebraic equation has that the algebraic expressions didn't have? An equal sign. That's right. See that word equation right there? It's not really, well, yeah, it is. Well, I should say this. See that word equal? It's kind of like equal. It doesn't have the L in there, but you got the equal part. So the equal means equal sign. So an equation has an equal sign in it. For instance, if I had, I don't know, A equals B. It's pretty simple, but that's an algebraic equation. And I couldn't really solve for that, but it's still an equation. Why? Because you have a left side equaling a right side. Everybody see that? Okay. Even something like this, x equals 3. Kind of looks like an answer, but that's still an equation. That's still an algebraic equation. X equals 3. You got an equal sign. When you have an equal sign, you have an equation. Everybody got it? So that means the left side and the right side are exactly the same thing. All right. So let's start off pretty easy. I'm doing examples right from the book. It's on section 05. You can find section 05 at the top, and you'll see these examples right in the books. So let's do this one first. All these will say solve. Now, it doesn't have to say solve for x because how many variables are in this equation? Just one. Variables. Only one equation, which is x. All right, so that's what we're trying to solve for. So we want to find out what x is equal to. What does this mean? This means what number, if I take 7 away from it, am I going to get 16? Some of you guys can just do it in your head, but I want to show you the steps you need to follow. All right, this is very important, especially in algebra, beginning of geometry, when you're just kind of reviewing your algebra 1 and that kind of stuff. Now, what you learned in algebra 1 was this. I want to get x by itself, so I have to get rid of that minus 7. Well, it's a minus 7. You're subtracting 7. How do you get rid of something in algebra? You always do the what? Opposite. Very good. So you always do the opposite of subtraction. This is subtraction. So in order to get rid of it, I've got to do the opposite. You're right. So I would add it. So I would add a 7. Now, you can't just add a 7 to the left side. They got to be balanced out. They got to equal each other. So that means if I add a 7 to the left side, that's right, I got to add it to the right as well. Whatever you do to one side, you can do that as long as you do it to the other side to keep that nice balance. All right, you follow me on that? Think of it as a scale. You ever see weights like that or balances? Maybe in science class, I don't know. You ever see that? No? Yes? Anybody here? Okay. Nobody's seen a balance where you put a weight on here and the thing comes up? Right, and then you put it, okay, well, I'm looking for a response, okay? Everybody's staring at me with this blank look, and I have no idea if you even hear what I'm saying, okay? You respond a little bit to me. Okay, so you have seen a balance. That's what an equation is. An equation is a balance scale. You got to keep it even. You don't want one getting higher or lower than the other one, all right? You want it right in the middle. So if I add a 7 to this, I have to add a 7 to the other side. All right, because it would be unbalanced if I didn't. Does it make sense? Yes, Mr. Hamrick, it does. Thank you. All right, so you add these up, and that's a 0. A lot of times we say cancel out, don't we? We say that a lot, and I'll say it a lot. I got no problem with that. But I want you to understand why they cancel out. Everybody look at it. Negative 7 plus 7 is what? 0. So really, what am I doing? I'm going to x plus 0, right? Which is just x. That's why it cancels out. We're going to do a problem here in a minute that they cancel out, but they cancel out for a different reason. These, they add up to 0. In this other problem, they're going to cancel out for another reason. We'll talk about that when we get to it. Now look at this. 16 plus 7 is 23. Circle your answer. There it is. Look, what did I do? I wrote down the problem, showed my steps, and then I got the answer. This is what I want to see on your homework. All right? Saying this a lot, aren't I? I say it a lot because I don't want people to say, well, I didn't know I wasn't supposed to. Believe me, I've gotten that kind of response a lot in the past. Hopefully I won't get it in here. All right, let's do this one. It's a little bit different because there's a plus instead of a minus here. It's the same idea. I want to get k by itself, so I want to get rid of the 31. That's what I want to get rid of. K can stay there. So that's right, I minus a 31 because it's being added. I always do the opposite to get rid of something. So I subtract a 31 from both sides. So now we say cancel out, but really what is it doing? It's adding up to what? To 0. Good. It's adding up to 0. Bring the k down. 10 minus 31, can you do that in your head? It's negative 21. Okay, if they're different signs, what do? You subtract the two numbers, take the sign of the larger number. All right? That's your answer right there. You circle it. Wrote the problem out, showed the work, circled my answer. All right. These are pretty easy, aren't they? Don't you wish they'd get a little bit more difficult, challenging? They will pretty soon. Don't worry. Here's another type. Let's do one where it's not being added or subtracted. That's probably kind of hard to see, isn't it? Let's go a little bit later. Let's go like that. What if we had this? 4D equals 36. Now what's going on here? Is that 4 being added to the D? What's it doing? What's it doing? What are they doing to each other? They're multiplying. Good. So what's the deal with algebra? You got to. How do you get rid of something? Do the opposite. What's the opposite of multiplying? It's divide. Okay. The opposite of multiplication is division. So I have to divide to get rid of the 4. So I put a little divide sign right there. We do it as a fraction in algebra. So I divide by 4. If I do that to the left side, got to do it to the right side. You're getting the hang of it. Now look. Again, we say cancel out all the time, don't we? But I want you to see what's happening here. Remember I said earlier, they canceled out in the other problems because they added up to 0. Did these add up to 0? No, but they do what? They divide. They don't add up, but they divide to be a 1. 1 times D is D. So I still got rid of the 4, didn't I? I just got rid of it by dividing. Why did I divide? Because it was being multiplied in the first case, right in the first place right here. So I divide to get rid of it. So that's just a D. Of course, I divided the other side. 36 divided by 4 is 9, and there you go. I know for some of you guys this is just way too simple, and I'm just kind of wasting my time. But I think it's important that we all start off on the same spot, because I really don't know your background. I've never taught, I don't think, anybody in here before. So I'm not really sure of what your background is. Some of you might have come from different schools. Some of you guys took different Algebra 1 classes last year, even if you went to Red Lion. So I want to make sure that we are on the same spot here. Let's take a look at this. It's starting to get a little bit trickier here, but it's the same idea. This 4 is being multiplied by D, so how did we get rid of it? We did the opposite, which is divide. Now, what's going on here with this x and this 8? Right. Well, what's going on with these two right now? They're not being multiplied. They're doing what? They're being divided. Right. It's x divided by 8. Okay, that was the question. What's going on between that x and the 8? They're being divided. Now you can answer me. What is the step? What do we do to get rid of the 8? Right, multiply, because we always do the opposite, correct? So we multiply by an 8. That'll get rid of the 8. But what are we left with on the left-hand side that we don't really want? That negative, okay? Because the 8s will cancel out, so I got rid of it. But I don't want that negative there. So how in the world am I going to get rid of that negative? Well, let's make a negative here. How did that help us? Because a negative, say it, Justin, what? Because negative times negative is a positive, that's right. And that gave me a positive x. That's what I want. I want a positive x, I don't want a negative x. Right with me on this? So look, I multiplied this side by a negative 8. Let's come over here and multiply this side by a negative 8. Whatever I do to one side, I do to the other. Now, why did I put this 8 over 1? What was the reason behind that? Well, because this is kind of a fraction, right? It puts it on top. So I didn't really have to do that over here, though, did I? So watch what happens. Negative times negative is positive. That 8 and that 8, they divide each other to make a 1. And what am I left with? An x. Now, what do we do over here? Negative times negative is positive 56, and there's our answer. What do you think? It seems like people, as soon as they see a fraction, they start, oh no, yeah, freaking out. Okay, maybe not quite that bad, but you know, they look at it and they worry a little bit and say, oh no, fractions, I can't do fractions. Well, this you didn't even have to worry about this being a fraction, did you? Because you got rid of the denominator right off the bat anyway. All right. Okay, let's do another one. This one's a little bit trickier. This one seems to be the one type that people really get bothered by. Look at these. Now, what's that 3/5? Now, look, don't answer the question you think I'm going to ask. Answer the question that I'm asking. What is that 3/5 doing to the x? It's not dividing. There's no sign here. I could put a dot if I wanted to, but but it's being multiplied, isn't it? That 3/5 is right next to the x. So really the 3/5 is being multiplied by the x. You could look at it another way. You could say it's 3 times x divided by 5 if you wanted to. You guys with me? Come on. Sounds like I'm losing you. You could say it's 3 times x divided by 5. It's the same thing. But I'd just like to look at it as 3/5 times x. Now watch what we're going to do. What do I have to get rid of? I got to get rid of the 3, right? And what else do I have to get rid of? The 5, the 5th, right? 3/5. So what I can do is instead of dividing by 3/5, that'd be kind of a pain. But remember when you were a little kid and you did division? Division of fractions was always what? What did your teacher tell you? Instead of dividing, you do what? Multiply by the reciprocal. Very good. Okay, it's a good word to use. Okay, the reciprocal means you just flip the fraction. All right. So instead of 3/5, what I'm going to do? I'm going to multiply by 5/3. Well, does that help us get rid of that 3/5? Absolutely, because the 5's cancel and the 3 cancel, don't they? Now, if I do that to the left side, talk to me. Got to do it to the right side. Very good. You can put that over 1 if you wanted to. All right, so look what happens. The 5 cancels out, the 3 cancels out. That wasn't so bad, was it? So getting rid of a fraction that's being multiplied is really not that hard. You just multiply by the reciprocal. You hear what I just said? To get rid of a fraction that's being multiplied by your variable, you just multiply by the reciprocal. Okay, that's the same thing as dividing, so I do it over here. So that all canceled out. I got an x. Let's see here. Does 3 go into 5 or does 3 go into 8? No, it doesn't. So I can't cancel anything out there, so I just multiply straight across. So on the top I get negative 40. On the bottom I get 3. Just leave it like that. There's no real good reason in an algebra problem to change that to a mixed number. Just keep it like that. I'm fine. I would actually prefer that you keep it like that. Don't try to figure out how many times 3 goes into 40 and then make a mixed number. Don't put it into a calculator and get a decimal. Don't do any of that stuff. Just leave it like this. And for some reason, I do year after year after year, I try to train you guys to leave it like this, but some people just are stubborn and they want to always change it to a mixed number or always change it to a decimal. I'm trying to give you less work to do. I'm trying to help you out here, right? So just keep it like that and you're done. Make sense? All right, just got a few more to do. Let's do another type. Let's get this out of the way. Let's move to a different color here. What haven't we used yet? Have we used that purple? Let's use that. Looks cool. They use Q in the example. I hate writing Q, so I'll just write it as an X. Is that all right? Now, look at this. This is more than one step. All those other problems were just one-step problems. This is more than just one step because look at the X. There's a couple things going on the left side instead of just being added or just being multiplied. Okay, look what's going on. This 8's doing what to the X? The 8's being multiplied. What's this 15 doing to this whole term? It's being subtracted, isn't it? So there's two things going on that we got to get rid of. We have to get rid of the minus 15 and we have to get rid of the 8. So here's what we do. The book sometimes says get rid of the constant first. The constant means the number that's being added or subtracted. All right? So whatever's being added or subtracted, that's what you get rid of first. Everybody with me on that? So what number is being added or subtracted to this X? The 15. So that's what we want to get rid of first. Don't get rid of the 8 first. Okay? I'm telling you. You could do it that way. I'm not even going to bother doing that though. The easiest way, the best way to do this is get rid of the 15. So it's a minus 15. We've already done this once today. How do we get rid of a minus 15? That's right. We add a 15 to both sides. Very good. So put a line, drop everything down. Look, this adds up to 0, doesn't it? Or cancels out. Now we don't just bring down the x. What do we bring down? The 8x. Now we add this up. So that's what? 64, is that right? Okay. So now we have a problem just like we did earlier. Remember that 4D equals whatever it was, 36? Now we have the same kind of problem. So now we divide by 8. That cancels out, or divides out to be a 1. 1 times x is x. 64 divided by 8. Does 8 go into 64? Yeah, 8 times, right? And then there's your answer. Show both steps. There's one step. There's two steps right there. It's a two-step problem. We good, Carol? I'll let you know as soon as we get done. Let me teach first, then I'll give you the homeworks. Let's do another problem. This is over. Yeah, I got a couple minutes. Okay, so here's another one. This will be the last one we do. Actually, I'm sorry. I got to do one before that. I'll go a little quicker, okay? If I go too fast, you can always go back on YouTube tonight and look. And slow it down, pause it, rewind it, all that good stuff. Here's what we need to do. We need to get the y's on the same side, because this is different because I have y's on both sides of the equal sign. So I got to get y on the same side. And the way I'm going to do this is I'm going to subtract a 6y. I've got to look at this as one term. I can't just get rid of the 6 by itself. Okay, the 6y kind of goes together. It's being added, that it's a positive 6y, so the way I get rid of it is subtract a 6y. Okay? That cancels out, bring everything down. 12y minus 6y is 6y. Bring everything else down. Now this looks just like the problem that we did earlier, doesn't it? Alright, so I subtract an 8 from both sides. That cancels out. 6y is that negative 13. Divide both sides by 6. And then I would just keep my answer just like that. Don't put it into a calculator. Don't try to even make it into a mixed number. Just keep it like that. It's perfectly fine. I'm okay with improper fractions. Some teachers hate them. I'm fine with it. Alright, just leave it like that. That's what you want to do. Alright, let's do another problem. This will be the last one. Okay? Look at this one. This is a little different, isn't it? What I would do with this parentheses, what is that 3 doing to everything in the parentheses? It's multiplying. So I use which property? What do we call that? Distributive property. Very good. Okay, you guys learned a lot in Algebra 1. Okay, you use the distributive property. So it's 3 times x, which is just 3x. Put a minus there. 3 times 5, don't forget that one. It's 15. Everybody see that? A lot of people tend to forget to multiply by that second one. And now, we've got basically, this is like the third time we've done this style of problem. Add a 15 to both sides. 3x equals 28. Divide both sides by 3. Does 3 go into 28 evenly? So how can I leave it? Just 28 over 3. Isn't that nice when you just leave it like that? It looks a little uglier than you're used to, but it's fine. It's a good answer. Okay, there's no reason to change it to a decimal. Absolutely not a decimal. If you really have to change it to a mixed number, then feel free, but I would keep it like this. Okay, I think it's easier, it's less work, and all that kind of stuff. All right, here's your problems. It's page P12, and it's going to be, now don't flip out, just wait until I write all this down. It's 1 to 35, just the odds. Okay, so it's section 05. So you're just doing the odds. 1 to 35, but you're just doing the odds.